What if the most dangerous space rock ever tracked is about to do something that no scientist on Earth can fully predict? On April 13th, 2029, an asteroid called Apophis, the size of a 20-story building, is going to pass closer to Earth than the satellites running your GPS right now. NASA says it will not hit us. But here's the question nobody is talking about. What happens to a loosely packed, tumbling, peanut-shaped pile of rubble when our planet's gravity grabs it and squeezes? Because the answer to that question is something every space agency on Earth is watching very carefully. And by the end of this video, you are going to understand exactly why. Picture this: June 19th, 2004. 3 astronomers at Kitt Peak National Observatory in Arizona point a telescope at a patch of sky and find something moving that should not be there. They track it for 2 days. Then equipment problems and bad weather shut them down. The object disappears. 6 months later, a team in Australia picks it up again. And when they run the orbital calculations, the room goes quiet. This rock, later named Apophis after the ancient Egyptian god of chaos and destruction, had a 2.7% chance of hitting Earth in 2029. That number does not sound dramatic until you understand what it means in context. For a space rock this size, that was the highest threat probability ever recorded in the history of asteroid tracking. It sat at the top of the global hazard list for over a year. Now here's the part that matters for what comes next. Scientists kept watching. They refined the data. They used ground-based radar to pin down the orbit with extraordinary precision. And by 2021, they confirmed Apophis is not going to hit us. Not in 2029, not in 2036, not in 2068. We are safe for at least 100 years. Case closed, right? Not even close. Because the more scientists studied Apophis, the more they realized the real story was never about whether it would hit us. The real story is what this thing actually is and what is about to happen to it. If this kind of deep space story is what gets you out of bed in the morning, subscribe to Space Aquarius because we are just getting started. Before we get into the strange part, you need a clear picture of what we are actually dealing with here. Apophis measures roughly 1,115 feet across at its widest point. Its longest dimension stretches at least 1,480 feet from end to end. If you want something familiar to anchor that to this asteroid is roughly the height of the Eiffel Tower, and about 3 NFL football fields laid side by side. Now think about what an object that size would do if it ever did hit. We are not talking about a fireball that burns up in the atmosphere. We are talking about a regional catastrophe. The kind of impact that flattens everything for hundreds of miles in every direction and sends shockwaves around the planet. But here is the number that really puts this in perspective. An asteroid this large passing this close to Earth happens, on average, once every few thousand years. Scientists are confident this kind of event has never occurred during all of recorded human history. And it has absolutely never happened while humans had the technology to actually watch it. April 13th, 2029 is a first. A genuine, unprecedented first. And the closer it gets, the stranger it looks. When radar got a clean look at Apophis, scientists were expecting something roughly potato-shaped, lumpy, irregular, but basically one solid mass. What they got instead stopped people mid-sentence. Apophis appears to have 2 distinct lobes, 2 separate bulging sections connected by a narrower neck in the middle. The description that kept coming up in research papers and briefings was the same one every time. It looks like a peanut. What scientists believe happened is that 2 separate objects drifted toward each other billions of years ago, made contact at extremely low speed, and stuck together, held against each other by nothing more than their own faint mutual gravity. This kind of formation has a name, a contact binary, and it is far more common than most people realize. Roughly 15% of near-Earth asteroids larger than about 650 feet show this same 2-lobed structure. Now here is why that shape matters enormously for what comes next. Think about any object made of 2 pieces joined at a single point. Where does stress concentrate when that object gets pulled or twisted? Not through the solid center of either piece. It concentrates at the joint, the seam, the narrowest point. For Apophis, that narrowest point is the neck. And in 2029, Earth's gravity is going to pull on that neck in a way that has never happened to this asteroid before. But before we get to that, there is one more thing about Apophis that does not add up. Most objects in space, given enough time, settle into a clean and predictable spin. The Earth rotates smoothly on a single axis. Most asteroids do something similar. Apophis does not. Apophis tumbles. It rotates around its short axis roughly once every 31 hours. But layered on top of that is a separate rocking motion, a slow wobble back and forth along its long axis that takes about 264 hours to complete. Scientists call this non-principal axis rotation. The plain English version is that this thing is rolling and rocking at the same time, like a football thrown by someone who has never thrown a football in their life. Here is why that matters. The way an object spins is a direct reflection of how its mass is distributed on the inside. A uniform, evenly packed solid spins cleanly. An uneven interior, denser in some places, hollow or loose in others, produces exactly the kind of complex tumble Apophis is showing us. That tumble is a fingerprint, and what it is telling scientists is that the inside of this asteroid is not simple, not uniform, and not what it appears to be from the outside. Nobody has ever measured the interior of Apophis directly. Nobody knows what is actually in there. And in 2029, Earth is going to find out by squeezing it. You already understand the force at the center of this story. You have felt it your entire life. It is the same force that pulls the ocean tides twice a day. Gravity weakens with distance. So when a large body passes close to Earth, the near side gets pulled harder than the far side. The whole object gets stretched. On the ocean, that creates tides. On a loosely bound asteroid passing 20,000 miles overhead, it creates something far more dramatic. Because Apophis is also tumbling, different sections of it rotate in and out of the zone of maximum gravitational stress during the hours of closest approach. Earth does not pull on it once and let go. It works the asteroid, continuously stretching it, compressing it, twisting it for hours. Scientists have run detailed computer models of this encounter. The results are consistent on the headline. The spin of Apophis is going to change. It could speed up significantly. It could slow down. The direction it points in space could shift. The stress concentrating at the neck, that seam between the two lobes, could trigger movement between the two halves. Surface material on steep slopes could slide and shift, exposing fresh rock that has been sealed away since the early solar system. Now here is the reassurance. There is a boundary in space called the Roche limit, the distance at which tidal forces become strong enough to tear a loosely bound object apart entirely. For Earth and an object the density of Apophis, that line sits at roughly 18,000 miles from Earth's center. Apophis passes at about 38,000 miles from the center. It clears the danger zone with room to spare. It will not be destroyed, but it will be changed. And the honest answer from every scientist who has modeled this encounter is the same. We do not know exactly how much. Here's what actually has researchers paying close attention, and it is not any single alarming prediction. It is the spread between the best case and the worst case. Every computer model of the 2029 encounter has to make an assumption about the interior of Apophis, the one variable nobody has ever actually measured. Feed in a stronger, more tightly packed interior and you get a modest result. A small spin change, minor surface shifts, nothing dramatic. Feed in a weaker, looser, more uneven interior, and you get something far more significant. A large spin flip, real movement at the neck, visible landslides, and a face of the asteroid that has never been exposed to sunlight before. The models cannot tell us which version we are going to get. Only the asteroid can answer that, and it is going to answer it in real time, in front of every telescope on Earth, and 2 spacecraft positioned specifically to watch. A large, surprising change in spin tells scientists the interior is weak and strange. A barely detectable change tells them it is stronger than the tumble suggested. Either result rewrites what we know about how these objects are built, and that knowledge matters enormously for planetary defense because the way you would deflect a solid rock is completely different from the way you would handle a loosely bound rubble pile. The 2029 flyby is not just a spectacle. It is the most important asteroid science experiment in history. And it is happening, whether we are ready or not. 2 spacecraft are already closing in. NASA's OSIRIS-REx, the same mission that flew to the asteroid Bennu, grabbed a sample from its surface and delivered it to Earth in September, given a new assignment the moment its primary mission ended. Renamed Osiris Apex, it is now on course to rendezvous with Apophis, right around the time of the close approach. Its job is to spend 18 months in orbit around the asteroid, mapping the surface in detail, measuring the chemistry, and documenting exactly how the encounter with Earth changed it. At one point during the mission, Osiris Apex will descend to within about 16 feet of the surface and fire its thrusters downward, deliberately blasting away the top layer of material to expose what is buried underneath. Scientists want to see what this thing is made of beneath the surface dust. The European Space Agency is sending a second spacecraft called Ramses. It is designed to arrive 2 months before the close approach, giving scientists a clean baseline measurement of the asteroid before Earth's gravity gets to work on it. That before and after comparison is going to be extraordinarily valuable. And on the ground, roughly 2 billion people across Europe, Africa, and Western Asia will be able to step outside on the night of April 13th, 2029, look up at the sky, and watch Apophis move across it with their own eyes. No equipment needed, just clear skies and the knowledge of where to look. For the first time in all of human history, the entire planet gets to watch a moment like this unfold in real time. Here's where things stand right now. Apophis is the most studied, potentially hazardous asteroid ever identified. Its orbit is precisely known. It is not going to hit us. But at its core, literally at its core, it remains a sealed box. A loosely bound, tumbling, peanut-shaped pile of rubble whose interior has never been directly measured. On April 13th, 2029, our own planet is going to run the one experiment that can finally open that box. And 2 spacecraft, hundreds of ground-based telescopes, and 2 billion pairs of human eyes are going to be watching when it does. Mark the date. If you made it this far, you already know this channel is worth your time, so go ahead and subscribe to Space Aquarius and drop a comment below telling us. Do you think what we find inside Apophis is going to surprise us? We read every single one.